Hi folks, welcome back to 1.7 part 2. And in this video, we're going to take a look at finding inverse functions graphically. So it turns out that any pair of inverse functions will just be reflections of each other across that identity function that we talked about in 1.5, that y equals x line, okay? So this y equals x line, let's go ahead and color that. So our y equals x. And if we look at our two examples down here, we'll see that this identity function, this parent function, is actually a line that the blue function and the green function are reflected over. Okay, you might have to turn your head sideways a little bit just to see that, all right? But they are indeed reflections. And same thing in our example over here. We've got our identity function, and we've got our original function and the inverse function, and they're reflected over that line, okay? Now you'll notice here that this point x comma y is the same as y comma x on the inverse. That's just like our a comma b and our b comma a. All right, so let's do some graphing, all right? We've got f of x equals x cubed. That's one of our parent functions. But if we plug in these values, let's see, -2 cubed is -8, -1 cubed is -1, 0 cubed is 0, 1 cubed is 1, 2 cubed is 8. All right, let's go ahead and plot these points. So we're going to start with -2, -8, -1, -1, 0, 0, 1, 1, and 2, 8. All right, and when we connect all of these, we end up with our cubic function, okay, x cubed. Now, before we do anything else, I actually want to draw in our reflection line, our identity function. And so that is going to go straight across that diagonal. It's going to hit every coordinate where the x value is the same as the y value. Now, if things are reflected across this line, let me use a different color here. Let's see if we can use the idea of switching the coordinates to go ahead and plot something, all right? So let me fill out the table first. So instead of -2, -8, I'm going to have -8, -2. All right, -8, -2. And instead of -1, -1, like I have here, I'm going to switch those and I'll get -1, -1, right? This will be 0, 0, this will be 1, 1, and this one will be 8, 2. All right, let's write these numbers down here before we forget them. -1, -1, 0, 0, 1, 1, 8, 2. And I'm going to go ahead and plot these points here. So -8, -2. This one is the same, this one is the same, this one is the same, but then we have 8, 2. So that's down here. All right. If we graph this and connect them, it'll look something like this. All right. And if we were in class, I would ask you to sort of lean your ear to your right ear to your right shoulder just a little bit. So you're looking at sort of a 45-degree angle. And then I think this line becomes vertical. And we can see that the pink and the blue, if we fold them over, will give us the same picture, okay? That means they're reflections of each other. And it turns out that the equation for this one is not x cubed, but for the inverse, it's actually the cube root of x, right? Now, later on, we might start to see this as x to the 1/3 power, right? But those mean the same thing. All right, so actually in this one question, we've got our numerical way of finding an inverse function. we've got our graphical way of finding inverse functions, and we've got a little bit of the algebra too, but that's for video 3, the algebra part, okay? All right. Now, if we look at this picture, right, we were able to just take every point and flip-flop them. And so the domain for, let's go back to the cubic one again. The domain for the cubic is from negative infinity to positive infinity. And the range is also from negative infinity to positive infinity, okay? Now, if we look at the pink function, domain is still all real numbers, or from negative infinity to positive infinity. And it turns out that the range is also all real numbers, because this keeps going up and this one keeps going down, okay? So the domain and range for the inverse function, we take the range of the, this is the range of the original function, which in this case happens to be negative infinity to positive infinity, right? And the range here is actually the domain of the original function. And that would be from negative infinity to positive infinity, okay? But you'll notice that the domain and range switch, because when we switch the x and y values, that's essentially what we're doing. We're switching our range and our domain, okay? All right, let's try one more example here. All right, so we've got f of x equals x squared this time, x squared. And so for x squared, we're going to plug in some values. Negative 3 squared is 9, negative 2 squared is 4, negative 1 squared is 1. All right, 0 squared is 0, 1 squared is 1, 2 squared is 4, 3 squared is 9. All right, let's go ahead and plot those points. 0, 0, 1, 1, negative 1, 1, 2, 4, negative 2, 4, 3, 9, negative 3, 9. And we're going to go ahead and connect them all with a nice smooth curve. Now let's talk about our domain and range here before we move on this time, right? Our domain is all real numbers because I can take any number, negative, 0, or positive, and square it. So from negative infinity to infinity, okay? But my range, if I look at the picture here, there's no parabola down here. In fact, it doesn't even start until we get to a y value of 0, and then we have everything above. So the way we write that is including 0 up to infinity, okay? All right, now, if we were to think about flip-flopping these values, okay, our domain of the original would now become the range of the inverse, and the range of the original would now become the domain of the inverse, all right? Let's see what happens when we draw our identity function line in again, y equals x. And I'm actually going to go ahead and start flip-flopping some of these points, okay? So I had 3, 9, that would be 9, 3. I had 2, 4, that's going to be 4, 2. And 1, 1, and 0, 0. And I'm going to go ahead and just connect these 4 points first, okay? Now, if I were to flip-flop the other points, these 3 that are hanging out up here, I would end up with 1, negative 1. I would end up with 4, negative 2, and 9, negative 3. And I'm just going to do this side in sort of a dashed line, and you'll see why in just a moment, okay? So if I were to go with that idea that I'm just going to flip all the x's and y's, and my picture, I would take this parabola, I'd flip it over, and I would end up with this okay? Now, the reason why I put the dashed line for the bottom half is because I want us to think back to what it means to be a function, okay? So what it means to be a function, graphically, we have to pass the vertical line test. And if I were to draw the solid pink part and the dotted pink part, it would fail the vertical line test because we see that it would cross twice, okay? If we go back to the blue function, the original function, we would see that this is a function. However, because it fails the horizontal line test, we actually don't have a one-to-one function, okay? The reason why one-to-one functions are important is because a one-to-one function means that the inverse will also be a function, okay? So if we zoom back to this one for a moment, this blue curve is a one-to-one function, passes the vertical and the horizontal line test. And we were able to flip-flop everything, no problem, and get another one-to-one function, okay? But in this case, we're not so lucky, all right? If the function is not one-to-one, then what we do is we take part of that function and we only reflect that part, okay? So it turns out that this pink dotted line here is not even part of the inverse function, okay? So when we fill in our table, we actually have 0, 0, 1, 1, 4, 2, 9, 3. And if we had wanted, we could have done something like 16, 4. Okay, but that didn't fit on our graph, so we didn't put that in there. Now this function, the inverse equation of x squared, is the square root of x, which later on we'll learn is really the same thing as x to the 1/2. But now when we see this square root of x, it might make more sense. How come when we do, let's say, square root of 4, I only get 2? I don't get -2, all right? So that's why I have the point 4 comma 2, but I don't have the point 4 comma -2, okay? So if we talk about domain and range here, our domain is now from 0 to infinity. So it'll be just like this part on the x-axis. But now our range is different too. It's not all real numbers because we don't get these negative y values. So our range is actually starting from 0 and going up to infinity again. All right, let's zoom in so we can get this all on one page again. All right, so there's your second example that talks a little bit more nuanced about the domain and range piece when we're looking at graphics of inverse function. All right, so this is it for part 2. Come on back for part 3.